Okay, so in Module 3, we've been learning about the multiplicative comparison, and we also have been learning about how to decide between the additive comparison and the multiplicative comparison. Well, today, we're going to go a step further and we're going to talk about how we can use division, so dividing, to solve a problem, a multiplicative comparison problem. So watch with me, and may not be comfortable with division just yet, but I promise you this is not hard at all, so just walk through it with me. Number 1 for Step It Out. Olivia is in the photography club. She takes 15 photos at a garden. That is 3 times as many photos as she takes at school. How many photos does Olivia take at school? Let's look at A. Use a bar model to show the problem. I can't read this one. Let N represent the unknown. Let's just fill out our bar model with the information that we've been given. We need to find out how many photos she takes at school. So that's our unknown. That's our question. So I'm going to put an S here because N is going to represent our unknown number. So I'm going to put an S for school because we don't know how many photos she took at school. But what we do know is she takes 15 photos at a garden, which is 3 times as many photos as she takes at school. There's those key words again, times as many, so you know we're multiplying here. So for our bar model, the second part, we're going to put a G for garden. And we know that she takes 15. That's the total number, so we can fill that in. And it's 3 times as many, so we've got to think about how many. We can think about how we can break down 15 into 3 different times. So if we think about counting by 5s, we've got 5, 10, 15. So 5, 10, 15 would give us 15 total pictures. So we break that down, or as you may remember calling it in lower grades, we called it decomposing the number. We broke it down into smaller parts. All right, let's look at B. Now we need to write an equation to model the problem. Use N for the unknown number. Now here's our problem, and if you remember from lesson 1, this is a comparison problem. Okay, this is a comparison problem. So now we're going to use the numbers that we have to fill in our equation. 3 times as many as N is 15. So 3 times as many as N is 15. Okay, so we'll fill it in just like it says in our comparison problem. Now we're going to use something called an inverse operation. And here's our vocabulary. So circle that yellow vocabulary box just so you remember where it's at for the test. Connecting to your vocabulary. Inverse operations. So inverse operations are pretty much the opposite of each other. So multiplication and division, they undo each other. So they show you the opposite. So we're going to use the inverse operation to solve this problem. So if we're trying to solve the problem using multiplication, we're going to use the opposite, which would be division. So how do we fill that problem out? Well, we're going to start with our larger number. We have 15. So we're going to put a 15 on this first line. And we're going to divide it by the other number that we have, which is 3. So 15 divided by 3. That kind of lends itself back to our bar model. If you look back up at our bar model, we had 15 and we divided it 3 times. And what did we get each time? We got a 5. So 5 is our unknown number. So Olivia takes 5 photos at school. All right, look at the turn and talk at the bottom. It says, how did you represent 3 times as many in your bar model and equations? How did we represent 3 times as many in your bar model and your equations? So some possible answers here. So thinking about this, your bar model shows that you have 3 groups of a number is 15. So 3 groups of some number is going to equal 15. My equation, which is here, shows that 3 times a number is 15. And 15 separated into 3 groups is a number. Okay, so we're looking at how we represented 3 times as many in the bar model and in the equation. So let's do a little bit more practice. This might be a little confusing for you, so let's practice it a little bit more together as a group. So let's go to page 62. Let's go to page 62. Make sure you have everything copied down so that you'll be able to return back to it. Okay, here's page 62. Step it out number 2. This year, 28 students are in the chess club. Last year, 7 students were in the club. How many times as many students are in the chess club this year than last? So look at those key words. Times as many. So we're going to multiply. Our question is, how many times as many students are in the chess club this year than last year? So let's look at step A. Write a multiplication equation to model the problem. Use n for the unknown number. So our unknown is our question. What are we trying to figure out? How many times as many students are in the chess club this year than last year? That's what we're comparing. So we're going to start our equation with an n. That's our unknown, our question. Well, we know, now let's look at what we do know. Look at your numbers that you have in your word problem. We know that last year there were 7 students in the club. So we're going to put a 7 here. Well, this year, there's a total of 28. So that's our total number between the 2 years. Now we've got to use that information or use a inverse operation, which means the opposite again, to try to figure out how many were in the chess club, how many times as many students were in the chess club this year than last year. So let's look at B. It says write in division. Remember, these 2 are inverse operations. They're the opposite. Okay? You're undoing each other. So let's use the numbers that we have to create our division equation. We have 28. So when we're writing a division equation, we're going to start with the larger number. So we're going to say 28 divided by 7 equals, this is our unknown, so we're going to put an n there for our unknown. Now you might be asking yourself, how do I figure this problem out? Ask yourself the question, how many times will 7 go into 28? So how many 7s do I need to make 28? Well, you can come over to the side and you can simply you can do this by adding. This is what I would do. You might have a better strategy, but this is just how I would do it. So I can say 7 plus 7, and I know that's a double stack, that's 14. Well, I'm going to add another 7. Remember, I'm trying to find how many 7s will go, how many 7s I need to make 28. Well, that's a better way to word it. So 14 plus 7, 21. Let's do another. And we can stop. We made 28. So how many 7s did I use? 1, 2, 3, 4. So right there, I found out that I had 28 divided by 7 equals 4. I need 4 7s to make 28. So this year, there were 4 times as many students are in the chess club. That's how I would solve the problem. You may come up with a really cool new strategy that you would like to use. If you do, share it with us in our Google Meet because, hey, everybody might have a cool strategy, and if you have a new one that I've never heard of before, I would love to hear it as well. Now let's look at your check understanding at the bottom. Leslie collects 24 aluminum cans and 8 glass bottles for the recycling club. How many times as many cans as bottles does Leslie collect? So we're writing multiplication and division equations to model and solve the problem. We're going to use n for the unknown. So let's look for some keywords here. Leslie collects 24 aluminum cans and 8 glass bottles for the recycling club. How many times as many, those key words there, how many times as many, that tells me that I need to multiply, and I'm going to use n for what I don't know. How many times as many cans as bottles does Leslie collect? I'm going to start out with n because that's my unknown. And then I know that she has 8 glass bottles. And I know I'm going to multiply, so I'm going to put a multiplication symbol. We know that she collected a total of 24 cans. Okay, so now we've got our multiplication equation, but we need to do an inverse operation. We need to undo that. We need to do the opposite. So we're going to divide now. So take the two numbers that you have in your equation, and how are you going to divide? You're going to say 24 divided by 8 equals n. I'm running out of space here. So again, do you have a great strategy that you use to figure this out? If not, you can do something very similar to what I did in number 2 above. You can simply say, how many 8s do I need to make 24? Or how many times will 8 go into 24? And I can come over here and work it out. I can say 8 plus 8 is 16. And that's 24. I can stop right there. How many 8s did I use? 1, 2, and 3. So we know that 24 divided by 8 is 3. So our unknown number is 3. All right, number 2, the students in the cooking club baked 12 blueberry muffins. They baked twice as many blueberry muffins as corn muffins. How many corn muffins do the students bake? So let's create our multiplication equation first. They baked twice as many blueberry muffins as corn muffins. You gotta know what that word twice means. That means 2 times as many. So we're gonna start with our 2. So 2 times as many blueberry muffins. We don't know, so we're trying to figure out how many corn muffins. So we put an N for our unknown, and then we know that she had 12 blueberry muffins, okay? So how many corn muffins does she bake? So we need to create a division equation here. Division equation, we're gonna take the numbers that we have. Start with your bigger number and say 12 divided by 2 equals unknown. We don't know what that is. And there again, you can come up with a great another strategy to figure out the division, or you can simply do it like this. 2 plus 2 is 4, plus 2 more, 6, plus 2 more, 8, 2 more, 10, 2 more, 12. How many 2s did I use? 1, 2, 3, 4, 5, 6. So our unknown is 6 corn muffins. Our unknown is 6 corn muffins. So check your answers. And again, if you have a really cool strategy that you think would be interesting to share with the class, make sure you bring it with you to your Google Meet. We want to hear your strategies. You can write it in the chat box. You can email me a new strategy. I would love to hear your ideas. Make sure you check your work and that you have completed everything in preparation for our tests coming up.